dx over dt equals radical. Can I move this radical here and dt there? So what is here then? Awesome. We're good? And now what I can do? Now I can integrate this from the beginning to the t final. And I can integrate this from xa to x final. If this function is ugly, I will take Wolfram Alpha or Wolfram Mathematica, whatever you have. You know that you can have free Mathematica, right? On your computers. Just using UCSB email address. You register. Okay, some people are surprised. Good. You just go to Wolfram Mathematica, you download it. As soon as you use your login name with edu in the end, ucsb.edu, it gives you temporary serial number. Then they check if you're really a student, and it gives you a permanent number, and you have free version of Wolfram Mathematica on your computer. Yeah. Sounds good? What is integral of 1? T final minus t initial. So after integration, this is just t final. Wow, this is pretty powerful. You can start at any point and select any arbitrary x final. You can integrate this, just one integral, and you get time of entire motion. That's really powerful. This is how you connect potential energy to time of motion from point to point. K&K does it for pendulum. Fully solved example, so please read that example. And we have time to do one more thing.
This is also for conservative forces, right?
Exactly, otherwise you cannot write potential energy. Potential energy only exists for such forces. I think I have one example that I necessarily wanted to do and one optionally if there is time. So let me start with the example that I necessarily want to do, and that will be item 14. Are you guys alright? Is smoke out of your ears or not yet? Not yet. Awesome. I forgot to check. Did you guys learn law of gravity? Universal gravity, or it will be later? Newton's law of gravity. You did, right? Okay. Because for some reason they use A. I will not use A. I will just use legitimate law. F is equal to G m1 m2 divided by r squared. Did you guys see that law? Awesome. K and K just uses A over r squared, which is fine. But let's be adults and use gm1 m2 over r squared. Alright, help me. What if I want to put here a vector f? How could I transform my right side if m1 is in the origin and m2 is somewhere in the world? And I use polar coordinates. Help.
Make r vector?
I cannot divide by vector. Good try. Yes?
Did you make m2 a vector?
Interesting. I never saw people trying to assign vector to mass because mass is a scalar value, and I never saw it used as a vector. Good try. Yes?
Make r the magnitude of the vector?
R is magnitude of a vector. It's polar coordinate r. Keep trying. Yes?
We could write an r hat next to it. So
Aha! We can write here r hat, and we're almost right, but there is still one issue. It's attraction. So here is minus. Awesome. Guys, thank you for contribution. In some classes, I have to beg people to give me your guesses, because when I ask you to guess, do you think I expect right answer on first attempt? No, it's really interesting to hear all your opinions. And this is exercise for yourself. When you think about something, unleash your brakes and think all possible things. If you solve problem for yourself or read the book and make versions what I just read. And then turn around and become critical to select right ideas and deselect wrong ideas. Awesome. Oh, I'm so happy I didn't erase this yet. I need it. Yay. All right, help. But actually, I need to describe R in polar coordinates. Do you guys remember what is dr in polar coordinates? You did it at the beginning of K and K, and we did it in Physics 8. Yes.
Theta dot theta hat.
Say again?
Theta dot theta hat. Or theta
Okay,
dot-
let me start with dr dt. What is dr dt? It is theta dot. Keep working. It's not the.
Then dr equals.
Listen, dr dt. It's not theta hat. Continue. R.
And then r hat. Theta hat.
Okay. Plus. R dot. D.
Yeah.
R. No, I mean, that's stupidity. Let's try again. R dot. Awesome. Amazing. So, velocity in polar coordinates has radial component that depends on rate of change of the radius, and tangential component. For example, if you are on circular motion, radius does not change, and this is just omega r. Alright, so let's now write dr. To write dr, multiply by dt. What is theta dot dt?
D theta.
Exactly. So we got, let me switch order. R, d theta, theta hat, plus. What is this? dr, r hat. Is everybody good? Amazing. Now, in order to find du, we need to dot multiply f and dr. This is f, and this is dr. Let's do it. I will erase everything except for this handy-dandy equation. As I erase, please think about your answer. Go. We do f dr, so negative du is equal. So we do f, and we'll multiply by dr. What is r hat dot theta hat?
0.
Awesome. What is r hat dot r hat?
1.
Amazing. So this is equal to negative g m1 m2 over r squared times 1 and times dr. Look at this beauty. Isn't that beautiful? Amazing. So now I can eliminate minus and I can integrate this function. Integral of this function is negative g m1 m2 over r plus constant. It is pretty popular in physics. Select constant in such a way that u at infinity, let me write here u of r, oops, is equal to 0 when possible. Is it possible? If r is approaching infinity, what is this? Plus c. If I want it to be 0, then c is. So it's not necessary, it's beautiful. You could select c equals to 3.5 times 10 to the 17 if you like it, or whatever is your favorite number. and this will be u of r is equal to negative g m1 m2 over r. This is amazing because it is gravitational potential energy expression. And I was thinking about a couple of examples. Since we have 2 minutes, I will do one example. And, alright, magic. Yeah, one more example will be item 15. One example, I was going to do modified example from K and K. And you know, I will tell you what I was planning to do. First of all, please read 512, solve problem 512. You will find out how this equation is used for the pendulum. Second, I was planning to do example 5.16, when there is beat on spring and on circular path, not on spring but on circular path. They solve it if you release mass from top and it drops all the way to the bottom. Also solve it when mass is released from 90 degrees position all the way to the bottom. I didn't explain what I mean, but when you will look at the problem, you will see what I mean, just for practice reason. I was going to solve the other problem. Let me set it up and not necessarily solve, because we have only 1 or 2 minutes left. Or what if this is LM? Nobody is surprised. But what if there is also attached a spring? K. And let's say this is L1. To solve this problem, you maybe need torques. Doesn't sound cool. But apparently, we can solve it really quickly for small angles at least using conservation of energy. Energy, 1/2 mv squared. I already can still by all the results. Let me use without parentheses. L squared, theta dot squared, right? And then plus potential energy. If this is y-axis with 0 here, then potential energy of mass m is plus mg negative L cosine theta. Pretty much, I did it already. Nothing new, except there is spring. If this is a small angle, then this is little horizontal displacement. It's not exactly horizontal, but for small angles, it is almost true. Plus 1/2 k. How big is that x? It's like arc length, right? What is the radius of this circle? L1 theta. So it will be L1 theta squared equals, constant. If energy is conserved, what is derivative of energy? 0. Let me steal 1 more minute. We started 3 minutes late, so let me steal 1 more just to finalize the deal. Derivative. 1/2 m L squared is constant, like we did here. What is derivative of theta dot? 2 theta dot times theta dot dot. Agreed? Plus, actually minus, and what is derivative of cosine? So negative with this negative will be plus mgl sine theta times
Theta dot.
awesome. Last thing, plus 1/2 k L1 squared. Let me distribute square L1 squared. What is derivative of theta squared? 2 theta, theta dot equals 0. And I'm almost done. First of all, I can cancel these 2's and these 2's. I can also cancel all theta dots. And I got amazing thing. Let me do it in 2 steps. M L squared theta dot dot plus mgl sine theta plus k L1 squared theta equals 0. The final answer, if theta is much less than 1, then sine theta is approximately theta. Agreed? Okay, let me divide everything by ml squared. And write my final answer. Theta dot dot plus parenthesis mgl over ml squared is g over l theta. Let me take theta out plus k L1 squared over ml squared theta equals 0. Look at that. We almost did no stress of the brain. We didn't think about it, but we got immediately that this is oscillating with omega squared. Let me write omega equal radical of g over L plus k L1 squared over ml squared. We got it for free. We just set up energy. Setting up energy is not big stretch of the brain. Then we differentiated it with clean white shirt. No spots there. Everything is beautiful. And we got pretty complicated solution. And no more equations. Last statement, and I'll tell you good night. Last statement. Do you see how easy is solve problem with energy and no forces? But if there is system more complicated, let's say two pendulums connected with spring, that will be two variables, theta 1 and theta 2. And this method will not work. But there is Lagrangian mechanics that you will learn in Physics 104, and you will see that really similar method as I used here works for more complicated system. You just need set up energy. That's it. There is a method that solves it really fast. This is little commercial for Physics 104. Thanks for letting me steal priceless